Hi everybody. In my previous video I explained how the 3x plus 1 maze works, and I mentioned it is related to the 3x plus 1 problem. In this video I'll explain what is the 3x plus 1 problem and what makes it such an intriguing problem. Okay, so what is the 3x plus 1 problem? Well, we have the numbers 1, 2, 3 and so on. And if a number is even, we divide by 2. And if it is odd, we multiply by 3 and we add 1. For example, 34. 34 is an even number, so we divide by 2. 34 divided by 2 is 17, which is an odd number. So now we multiply by 3 and add 1. 17 times 3 is 51, plus 1 is 52, which is an even number, so we divide by 2, which gives 26. 26 is also even, so again divide by 2, which gives 13. 13 is odd, so times 3 is 39, plus 1 is 40. And then we continue. 40 is even, so 20. 20 even, so half 10. 5. 5 is odd, so times 3, 15, plus 1 is 16. Divide by 2, we get halves, 8, 4, 2, and 1. So what do we see? 34 reaches 1. And if we look at other numbers, it turns out also those numbers reach 1. And it may take a little longer, but also very large numbers reach 1. So what is the 3x plus 1 problem? Every starting number reaches 1. That is what the 3x plus 1 problem is. Clear, right? We just have to know what even and odd is, and divide by 2, multiply by 3 and add 1, and then every number reaches 1. So what is the problem here? Well, actually it is very easy to state problem. The final statement, every starting number reaches 1. There is no proof that this statement is actually true. We simply don't know if every starting number reaches 1. And this problem was already proposed in 1937 by Collatz, a mathematician. And there were many mathematical discoveries and big proofs between 1937 and now, like Fermat's last theorem, to name the most famous one. But no one came close to proving Collatz conjecture. And it is a known problem. Many people, many mathematicians, including me, spent a lot of time on it. So the 3x plus 1 problem is such an intriguing problem because it is so easy to state, especially to mathematical standards, but close to impossible to solve. And what makes it even more enticing, from the problem we directly have a few leads that we want to follow. For example, well, maybe you already thought of this. If we reach a power of 2, so 2, 4, 8, 16, 32, 64, etc., then division by 2 will bring you straight to 1. So we need to show that every number reaches a power of 2. And they checked a lot of numbers. They actually checked all the way up to 87 times 2 to the power 60, and all numbers lower than that number with computer power. And all those numbers, well, that's a big number, right? 100 and one with very many zeros. All those numbers up to this huge number, all those numbers reach 1. And that actually makes you wonder why? Why the 3x plus 1 problem? So we have this division by 2 times 3 and adding 1. Why do we do it? And what's the point? What can we learn from this? And if we checked already to this huge number, all numbers reach 1, then, well, even if there are infinitely many more, then why to check those even more? Well, actually, the thing is with this problem, it may not have a direct purpose in the practical world, but problems themselves are very motivating. And from problems, we reach new results, which can be used in other parts of mathematics. For example, my studies gave me these two weird formulas and lemmas, which I would not even think of if I would see them for the first time, or I wouldn't even come up with them. And now they just appear during my research. They just pop up in a certain sense. So that is what makes a problem really relevant and really motivating to pursue finding a solution, because you don't know actually what you may find on your way, right? Okay, so back to the problem. Easy to state, immediate exploration, extraordinarily difficult to solve. That is what makes it such a good problem. And in the next video, I'll tell more about immediate exploration. I hope to post that video soon. And if you want to know what is the connection between the 3x+1 problem and the 3x+1 maze from my previous video, then I will also make a video of that after that. So thank you for watching. If you want to know any details, they are in the description. Also, feel free to leave a question or a comment within the comments, and I'll reply to you. Okay, thank you for watching. Bye.